For this problem, I just want to point out that there are several ways to write the same thing. We could have this trinomial times a squared b and all of that to the power of -1, which just means that we're going to divide that trinomial by a squared b, or we're going to divide that trinomial by a squared b by putting it over the trinomial or underneath the trinomial. Either way, any way that these are written, we're still going to solve them the same way. We're going to create those three fractions because this is three terms on top of this fraction. We're going to have 3a squared b over a squared b. We're going to subtract the 6a cubed b to the fourth over a squared b, and we're going to add 5ab squared over a squared b. And then we just treat each of these like an individual problem, and we deal with it like it's one term. A squared divided by a squared is going to cancel out, and b divided by b is going to cancel out. So we're just left with this 3. And then 6 divided by 1 is 6. And then we're going to do a cubed divided by a squared. When I'm dividing fractions, I subtract the exponents. So 3 minus 2 is 1, a to the power of 1. And b to the power of 4 divided by b to the first is, I'm going to subtract 4 minus 1 is b cubed. This last one is going to give me some negative exponents. So I always put them on the top of my fraction and deal with the fact that they're negative later. So first I have my 5, and a to the power of 1 divided by a squared is going to be, I subtract them. 1 minus 2 is -1, and then b to the power of 2 divided by b to the first is going to be b to the power of 1. Do I like negative exponents? No, I do not, so I'm going to put it on the bottom of my fraction. So the final answer is going to look like 3 minus 6ab cubed plus 5b all over a. It's just this third term that this a goes underneath, not the whole trinomial. And that's the final answer right there.